Howdy everybody, I'm Christopher. My good buddy Zach's pulling the van right now. We're continuing our quest to build an electric powered Vanagon. We're back with you here today on the first cold day of the season. We got a couple things left to do on the van. Let's take a look real quick. In front of me here, you can see a big pile of parts that still need to be processed. They need to either go on the van, they need to be reconfigured in some sort of way, or they need to be tossed out. We have a big old airbox here. We have a big brake kit for the front here. We have some Volkswagen parts that maybe somebody might be interested in, who knows. And we have parts that need to either hit eBay or the junkyard. Under this blanket here, we have another shelf of items that need to be dealt with as well. We have a mess of electronics, some buttons hiding in here somewhere, a steering wheel, an adapter, a brake booster, a power steering motor, some brake cables that probably won't go back on. But we have these things as well. So what we're going to do is we're going to pull the van in, talk about what we're going to work on. Nope. Keep going. There you go. Nice. That's one of the things we got to work on, is that parking brake. It's going to be can controlled before long. So we got the van in and the fire going. Let's talk about what we're going to do in this episode. What do you say, Zach?
Yep. Hi, welcome back everybody. I'm Zach, he's Christopher, and we're moving on to phase 6.25. I don't know what that means, but it does mean this big old airbox is no longer going to fit. And so we have to figure out a way to get maybe some defrost and some other options in a much smaller package, which probably means custom fabricated aluminum. And this guy is power brakes. Part of the reason that that's not going to fit anymore.
And Jack, can you show us where the brake booster is going to be in relation to the airbox?
The brake booster in relation to the airbox is going to be somewhere about here.
Yeah, we're gonna have to figure something out. We have enough room under the dash, just not with both items there. And if it does become tricky, we have some other things. We have a oh geez, not lots of jizz. Brake fluid, man, sorry about that. We have a brake reservoir relocation part item that may or may not be used, but we have it available to us. This is a Bosch iBooster, comes off of a Tesla Model 3, I want to say. They also came on a couple of Chevy Bolts, and they're in other cars. I mean, Bosch makes parts for all sorts of people. We got this one specifically because of the attachment point here. That will be important later down the line, hopefully. So we're gonna rip the dash off, we're gonna take a look underneath and see what we can do to start this process. Because right now, it's only an idea in our head and we still have to kind of figure out the details. Maybe we'll plug in the dash too, that'd be nice. Be able to see how fast you're going.
The novelty.
One of those unnecessary features. Okay. What's a grunt going on over there, man?
It's not the working that's hard, it's the working while doing the limbo that's hard.
Yeah, the angles. Oh, it's like we've done this before, huh? Pros. You know, looking at all this space, you'd think we'd have enough, right? All right, I'm gonna move the camera and show you where the issue actually is. This is our stock brake booster. It uses a vacuum to actuate a diaphragm on the inside of this here assembly, and that assists you in putting more than your foot can press on this valve, more or less. Right?
Since we don't have any vacuum anymore, because vacuum is generated by the internal combustion engine, we don't have power brakes anymore. Hence, this guy. It's a bit larger. The funny thing is it almost fits, I think, but it doesn't.
From my angle, it looks like the other one stops here, kind of midway on this reservoir. Now what we could do is we could jigger it up in there, right? And then use that remote reservoir to move where you put the fluid in, but then we have to figure out where you're going to put the fluid in, and then that directly conflicts with our instrument cluster. That's not really something I want to be messing with. So the solution we're thinking is it's going to go in sideways.
Doesn't that still mess with where you put the fluid in?
It does, but you know, it's the fluid area is going to be over here-ish somewhere versus over here-ish somewhere. All right, the solution we're gonna attempt is to use this big old empty space that previously used to occupy the air box. Kind of do something like that, where it goes in sideways.
Yep, and so we'll have to come up with some sort of linkage that converts this direction into this direction. So we'll have to turn it 90 degrees.
All right, I have a paper diagram here to show you the concepts that we're going to be working with. This T-shaped looking thing is our brake booster. The big old square bit at the end is where the vacuum reservoir is, and this is where the hydraulic bits go. In order to actuate this, what we have to do is we have to plunge into the reservoir to actuate the internals. Okay, so brakes on, brakes off. Very similar to that. We don't have enough area in this top bit in order to put our new brake booster. So what we need to do is we need to rotate everything 90 degrees. And that's what this next one is. And we can see it demonstrated like this. In the event that the brake boosters have a different throw required to actuate them, what we can do is we can move the pivot points of this triangle in or out in order to get different throw lengths. In this case here, we move the pivot point in so that we get a mechanical advantage. A relatively short throw length here will give us much more action at this end. Now, I don't imagine that it's going to be this drastic when we actually go to build the final product, but this will allow us to have a full pedal press match the desired throw length of our electronic brake booster. Probably should have done this before we took this out of the van. But we made a template. We mark where the vent is. We're gonna put the dash back in, and then we're gonna use this cardboard to mark what space we have available to work with.
Simple but effective. Cardboard's just taped to the windshield. Roughly marks out the space we're gonna have inside. And when we take it out, it'll still be there.
Yep, and we got a little dangle bob to show us how far the vent pokes down into the void.
Don't forget your dangle bob.
That's what I always say.
Well, howdy there, friends. I'm just taking out a brake booster, that's all.
First things first. Gotta take the old brake lines off. Yeah, buddy. Got it. There we go. Yay! Man, tons of space. Surely we can make something fit in there. That's what she said. Here you can see the factory brake booster. Here you can see big aluminum bracket. It is actually the pedal assembly. So, back here, we're gonna have to take the booster off of it and reuse that bracket.
What would you call that, Zach? A buggy? Or a cartridge? Or a
Stand.
a stand?
I mean, it's like we're putting it on display. I mean, it's like, there it is. A holder.
It's definitely not going to roll away.
A jig. It's kind of a jig, because yeah, I'd say it's a jig.
A jig. Okay, we'll go
It's
with
a jig.
Okay, we got the bracket mount stand display piece in location, and we're gonna kind of see if we can't wiggle it around and find a good spot for it. We want it as far to the left as I think we can get it, and a little bit lower than the dashboard guy right there. That wiggle business. Well, what we're going to do is we're going to build a bracket here that goes to this whole pattern, a bracket here that goes to this whole pattern at 90 degrees.
Yep.
And then we're going to make a top plate and a bottom plate, connect them at whatever angle it needs to be, and then we're going to run a pin from the top plate to the bottom plate, and that pin's going to have a pivot on it. Day 2, and this is how the shop looks. I need to talk to management and figure out why it's such a mess. We have our brake booster on a sled, and our sled is adjusted so that the angles are appropriate to this cross member holding it up in the position that we want, sort of. Got to adjust that wedge a little bit. And we're starting on this. A wooden template for what is ultimately going to be the metal bracket. So we're poking around, learning some things, figuring out what it's going to look like, and making some progress. Shop's still a mess though.
Ladies and gentlemen, boys and girls, this wonky looking piece of work right here is a rough model of our linkage. Let's see how clearly you can see it here. Here we have a pivot point. Here we have a right triangle. And here we have 2 more pivot points. So that when we apply force here, it transfers to here, but we probably need to undo this so that we can actually show that. So as you can see, linear motion is transferred 90 degrees in order to actuate our brake booster. Boy, all that work, and that's pretty much all I got to say about it.
Yeah.
We made something go 90 degrees.
No, well, we didn't make things go 90 degrees. We know what the shape is that we're trying to make out of metal. Just in case you were curious, this is not going to be run in the van. This is what we like to call a prototype. Yeah.
You can see our template here that shows where our dashboard stops and starts, and because of that we know that this is all going to fit.
Alright, take a look. We have a beautiful brake booster bracket mock-up template thing out of wood. I mean, it works, it does the job. What we're going to do next is we're going to CAD that up, take it to my dad's shop, cut it out of metal. Alright, it's time to digitize our wooden bracket. We have to do that to get it in the computer so that ultimately we can cut it out of metal. This will be done on a plasma cutter. Our software suite of choice right now is Fusion 360, and the tools we're going to use normally would just be a caliper. That does most everything you need. It has a fancy digital readout and it works quite well. In this case, we're also going to bust out a ruler and a set of dividers. Now what this will allow us to do is this will allow us to get in and poke at different dimensions and figure out exactly what shape and size certain things need to be, and then pull that over to a ruler and get a measurement that way. Now, I'm not going to go through the entire process because this video is quite long already and it'll be split into two parts. But for today, what I want to show you is a couple things that I did. We have our bracket. Okay. And if you'll remember, we spent quite a bit of time getting this top surface level right here. This is because the brake booster is going to have square, nice measurements. And because back in the day, when Volkswagen was designing the bracket that this is going to mate up to, they used nice, round, even numbers in the process somewhere. So it's just a matter of us deducing that. So we spent a lot of time here, and that gave us a solid measurement when it comes to the interface between these two planes. Okay. This actually worked out to be a nice, even, round 65 degrees between this diagonal face here and the horizontal plane. That is a critical measurement for a digitization process, and it'll basically see us through the end. Taking a look at our physical model here, you can see artifacts of the creation process. We took measurements of these bolt holes, and they were 72 millimeters square. This circle was right in the middle of these four holes, and you can see where the center line actually is. The diagonal bracket is just a little bit lower from the vertical bracket. And what we're going to do is we're going to take a critical measurement here and insert that into the computer. And that's this guy, the measurement between these two lines here. So given the critical dimension of 65 degrees and this offset, we can basically digitize this entire bracket. Okay, here you can see the model that was created. We fast forwarded through time because honestly there's 1,000 better tutorials on Fusion 360 than I could probably offer you at this point. If I'm gonna be honest, this took me all day to work out. Not because it was incredibly difficult, more so that I didn't know exactly what I was doing. And when you don't know exactly what you're doing, sometimes you got to take 2 steps forward and 3 steps backwards. That's a net negative step is what it is. But what you can see is if I start revealing some of our sketches, you can see those critical measurements that I was telling you about. You have the horizontal line running across the screen here, and you also have on this diagonal plate these layout lines that I was telling you about. You can see that our squares are 72 millimeters square right there. What we have is we have the 65-degree angle, that critical measurement that we were telling you about. And you can kind of see how it's assembled. And that's basically 1-to-1 with what we have here. Granted, it's much more cleaned up on the computer, but it's a 1-to-1 scale representation. Now, any one sketch in this project is going to be easy to do because it's just a matter of taking numbers off of your object and entering them into the computer. What it becomes difficult is referencing these complex angles and how they interact with each other, because there's not really a good way to do it. But like I said, we have layout lines in the physical world, therefore we can make layout lines in the digital world. And you can see that what we did is we took these important lines, the horizontal one here and the horizontal one here, and we kind of lowered the diagonal plate, the required 13 millimeters. And that's coming straight from our physical object right here in our real world, that 13 millimeters. We got our 65-degree angles and we got the 13 millimeter drop. And at that point, things just start to fall in place. That's the beauty about software, you know, it does a lot of the work for you if you can just kind of get that first step started. One of the things I wanted to show you while we still have this model open and before it goes to the plasma cutter is this interface between the two pieces. What it's ultimately going to do is it's going to give us 2 positive stops in order to kind of smush the pieces up together at the correct angle where we don't have to do any guessing. And we did that via tabs and slots. We're going to hide this booster plate and you can see the tab, and then we'll hide the diagonal plate and you can see the slot. Now they mate together, and what they do is they provide that exact dimension in order so that when it comes to welding there's not really much thought necessary, because if those 2 pieces fit together, they fit together at the right size, angle, and dimensions. All the magic stuff just happens. I followed a tutorial on the internet, not necessarily showing me how to do this, but like giving best practices. And one of the things that they talked about was the corners. Now, when a plasma cutter or a laser cutter is turning a corner, the inside corners are gonna have a problem. So what I did is I added a feature, just a little tiny circle that allows the plasma cutter to go wide, basically, so that when it's turning the corner, it doesn't give you the funniness that would normally be there. It actually goes wide, cuts more than it needs to, and it gives you the clearances so that it'll fit up nice and proper. We also modeled in a bunch of dashes in order to thin the metal, in order to let it bend at the correct point. And these guys, hopefully they'll do their job, but they are dead in the middle of this bend. That was kind of a pain because I probably didn't do it right, if I'm being honest, but I'm really hopeful that it'll turn out well. There are some areas of concern that I have at this moment, is how close this bolt hole is to the bottom. So we're gonna have to be careful when we go to bend all this stuff and we go to weld it and we go to actually place the bolts in, because these bolts will be captive. Okay, well, we're back in the shop with our bracket. We have the digital files and we're ready to put some tools away. But before we go, there was a question that was asked by a couple people we've been talking to prior to this, is why don't we just put a vacuum pump in and not deal with any of this nonsense? Well, I got one answer for you. Zach may have a different one, but my answer is this. It's loud. loud, it's obnoxious, and I already have one vehicle that struggles with vacuum issues. So, there's that. Well, in next episode, we continue. We'll take our digital files off to the cutters, visit my dad, and cut some stuff on the plasma machine. So that'll be super fun.
Yeah, I'm looking forward to it. I think it's going to be really rad. And we'll just continue this brake booster bracket journey.
Brake booster bracket.
Alliteration. Look it up.
Well, that's Zach's wife calling, saying, "Where are you?"
So, it's time to go.
It is. See you in 2 weeks, guys.
Be good, people.
It is your wife calling.
Hello.